You absolutely cannot miss these two LTX 2.3 LoRAs. With them, you can easily pull off video-to-video generation. The first one is called the Union Control LoRA. Just like traditional ControlNet, you can use pose maps, depth maps, or edge maps to control the generation of your target video. The second one is called the Motion Track LoRA. By drawing trajectory curves, you can control the movement of subjects within your video. In this video, we will show you some totally different ways to play with them. We will still use pose, depth, and edge maps to control video generation. But you will notice that the videos we generate will have a much stronger sense of storytelling. Similarly, when using trajectories to control video generation, we can control not only the movement of the subject, but also the movement of the camera. We can even easily simulate zooming in, zooming out, and scene transitions. These two LoRAs were officially released by LTX, and you can find their links on Hugging Face. To use these two LoRAs, we also need to install an extension. This extension is also officially released by LTX. Inside this extension, we can find the corresponding workflows. Fortunately, this workflow is actually pretty much the same as the official ComfyUI workflow we have talked about before. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online cloud platform because whenever new extensions or models drop, they are always the first to support them. Besides that, Running Hub provides an online community platform for ComfyUI creators, where you can find tons of inspiration and practical workflows. Let's first take a look at the Union Control LoRA. First, you need to understand that this is not a two-stage workflow. It only includes the video generation part and skips the upscaling part. The workflow you are looking at right now is one I modified based on the officially released version. First, for loading the main model, I used Kijai's model instead of the native ComfyUI one. The reason is that Kijai's model uses less VRAM, but there is no noticeable drop in generation quality. Aside from loading the base model, we have a very important node here called the ICLORA loader. Using this node, we can easily load our ICLORA. The name of this LoRA is quite interesting. First, it is called Union Control LoRA, meaning it internally supports multiple control methods like the pose maps, depth maps, and edge maps we frequently talk about. It consolidates all these control functions into this single LoRA. Additionally, there is a very important keyword in its name, reference 0.5. This means its reference strength is only 0.5, which leaves the model with more room for creative freedom. Based on this logic, we recommend setting the model strength to 0.5 as well. Moreover, the output of this node, besides the usual model, has a very important parameter called the latent downscale factor. You can think of it as the scaling coefficient for the latent. We will need to use this scaling factor later when processing our reference video. Since the entire workflow is video-to-video generation, we absolutely must have a reference video. First, we scale the video. The rule is to scale its shortest side down to 544. Then we can use ControlNet preprocessors to extract the control signals we want, which are our standard edge maps, depth maps, and pose maps. When generating these control images, the resolution we use is typically 512. That is exactly why we need to scale the video down to 544. Next, we will use that scaling factor we just mentioned. We multiply this factor by 32 to get a scaling multiplier. We use this multiplier to scale our control video, giving us the final resolution of the control video. This resolution is actually the final resolution of the video we will generate. As for the reference image, it is completely optional. You can have one or leave it out. If you have one, it becomes an image-to-video process. If you don't, it is a text-to-video process. Here we will stick with the image-to-video approach. The image processing method is very standard. First, we scale its longest edge to 1536, and then we compress it, keeping the compression factor at 18. Now comes the most important part. How do our reference image and LoRA influence the model? Let's look at the reference image first. Here we will use a new node called LTX image to video condition. Using this node, we can inject the reference image as a generation condition into our latent. Next up are our control signals. If we want our control signals to take effect, we will use a node called Add Video ICLORA Guide. Let me give you a quick breakdown here. We call these types of nodes reference generation nodes, and their basic functions are pretty much the same. Let's look at two similar nodes. One comes from WAN 2.2 and the other from KJ nodes. Their purpose is to treat the control image as a condition and add it into our latent. In their inputs, you will typically find positive conditions, negative conditions, and our reference image. On the output side, it is usually the modified positive condition, negative condition, and our latent. What you need to pay attention to here is that when using this node, we must pass that scaling factor into it. The subsequent sampling process is basically identical to LTX 2.3's standard text-to-video and image-to-video workflows, so I won't repeat it here. Now that we understand the basic structure of this workflow, let's test it out. Here, we use a beautiful woman as our reference image. And for the driving video, we use a video of some intense dancing. Let's first set the LoRA strength to 1. Then we will test the depth map, pose map, and edge map one by one. You will notice that no matter which control image we use, the final results we get aren't particularly great. The characters basically all collapse. Why does this happen? There are actually two main factors. One is the LoRA strength, and the second is the intensity of the motion in the reference video. First, we highly recommend tweaking the LoRA weight down to 0.5. Next, we select a reference video with much smoother movements. Now let's check the generated result again. This way, things look much better. But if you only use these basic techniques, the videos you generate will just be average. If you want to get videos with a much stronger sense of storytelling, we are going to teach you a secret trick here. Inside LTX, there is a built-in prompt generator. This is a very important feature in the LTX workflow. In the past, we always wrote prompts by hand. Writing prompts this way consumes a lot of energy, and our handwritten prompts aren't always very precise. Later on, we usually started using large language models to help us write prompts. Actually, the LTX 2.3 workflow has a built-in node for this, so we don't need to rely on third-party models to write fantastic prompts. You need a mindset shift here. We used to think that CLIP was just a text encoder, but you will find that nowadays, most text encoders are actually large language models. Since it is a large language model, it inherently has the ability to generate prompts. So how do we do it? This is where we use a node called Text Generate LTX to prompt. This node is also officially released by ComfyUI. Many folks have noticed this node, but they aren't using it quite right. They usually write a short prompt, hoping the large language model will expand and rewrite it for them. The results you get from doing that aren't particularly good. So what is the right way to do it? We still need to write a prompt engineering template. Here, I am using a prompt engineering template we developed previously, specifically designed for writing LTX video prompts. Before, we always used it inside AI Studio. Now, we don't need to go through all that hassle. We can just drop this prompt engineering template right in here. We provide some text instructions in the user input. This way, we can generate incredible LTX video generation prompts. For the inputs of this node, besides our large language model, which is CLIP, you can also choose to pass our reference image into it. Then we can pass the generated prompt into our text encoder. When we adjust the weight to 0.5, the model has much more room to play around. For example, in the text prompt, we used phrases like a stolen kiss and a cheek-to-cheek kiss. The prompt generator will help us create detailed prompts, and you will notice that the generated results are completely different, but without exception, they all have way more detail and are full of narrative depth. To test the effectiveness of this prompt generator, I tested a huge number of videos. Among these videos, some contained more complex actions, some had stunning lighting, and some even featured unexpected plot twists. Therefore, using prompts created by the prompt generator will give your videos a much higher quality cinematic texture. Next, let's talk about the other LoRA, the motion track LoRA. The overall workflow hasn't changed all that much compared to the union control LoRA. We mainly need to pay attention to the following points. The first is loading the LoRA. We switched the loaded LoRA model to the motion track LoRA, and for the weight value here, you can set it to 1.0. Since the purpose of this LoRA is to control the generation of the target video using trajectories, we need to draw a trajectory curve, which serves as our control signal. Actually, you don't need to treat trajectory control as some super mysterious thing. It is really just another type of control signal, not much different from our depth maps, edge maps, or pose maps. If you want to draw trajectory curves, we are going to use this node below called Sparse Editor. When you right-click your mouse, you will see commands to add nodes, add splines, delete nodes, and delete splines. Using these commands, we can draw all sorts of curves on the image to represent the movement trajectory we want for the video. What you really need to pay attention to here is that every node on the trajectory curve has a number. A newly added spline will have two nodes by default, numbered 0 and 1. Here, 0 is the starting point, and 1 is the ending point. This also dictates the direction of the movement. Pay attention, absolutely do not mix this up. If you get them mixed up, the motion trajectory in the video will be the exact opposite of the curve you drew. The motion track LoRA actually has a lot of fun use cases. Besides the familiar character movement control, it can also control camera movements and scene panning. Let's demonstrate these one by one. First, let's look at the basic usage. We will start by uploading a reference image of an ancient-style beauty. Next, we will draw trajectory curves for it. I highly recommend that you first right-click and delete all existing splines. This is extremely important because when the image resolution changes, it is possible that previously drawn curves won't be visible on the new image, but they do still exist in the background. Let me demonstrate this for you. Right now, we have a landscape image with 5 splines drawn on it. Now, we are going to switch the image from landscape to portrait. When we run the workflow again, you will notice the node says there are 5 curves, but you can only see 4. If you only delete the 4 curves, you see you missed 1. And because of that, your final trajectory curves will be inaccurate. This situation will directly ruin your video generation later. Therefore, you need to build a good habit. Before drawing new trajectory curves, we must completely clear out all the previous ones. Let's continue our test. We can draw these 2 splines. One indicates the movement direction of the beauty's head, and the other dictates the movement direction of her left hand. Next, we run the workflow and get a fantastic video of the ancient-style character dancing. However, at the very end of this video, you will see a background switching effect. It changes from a solid color background to a realistic background. So we can try adding the following into our negative prompt. This way, we can control the frame and prevent cuts and transitions. Let's generate it again, and you will find that the result the second time around is much better. What we just covered was the basic usage of the motion track LoRA. Now let's look at its advanced usage. There are 2 advanced use cases, camera control and scene panning. Let's look at camera control first. We upload a portrait image of a beautiful woman. We draw 4 curves, all starting from her face and radiating outward like a starburst. This indicates the camera is starting to push in, making the scene zoom in. We also recommend adding a keyword like zoom in into the prompt generator. Let's look at the generated result. As you can see, there is a fantastic camera push in and character zoom in effect. Using a similar method, you can also achieve a zoom out effect. Note that the trajectory curves for zooming in and zooming out actually look identical. The only difference is that the positions of the starting point and the ending point are swapped. The second advanced use for motion track is overall scene panning. For instance, I have a reference image here depicting a beautiful woman flying in the sky. Now, my trajectory curves are drawn like this, stretching all the way from the far left of the frame to the far right, with the 4 curves basically parallel. You will find that we get an incredibly cool camera panning video. Of course, I believe there are many more ways to play with these 2 LoRAs. If you are interested, you can dig into them yourself. So today we explained how to use these 2 ICLORAs. We also showcased some advanced application techniques, such as using the prompt generator and techniques for drawing motion trajectories. I hope this is helpful for your video generation. That is all for today. What are you waiting for? Go try it out yourself. Follow me to become someone who truly understands AI.